In this video, we're going to go ahead and look at the area of a sector of a circle and the area of the segment of a circle. We'll just review a couple definitions before we do that. The central angle of a circle is an angle whose vertex is the center, so in this circle here, center B, and whose sides contain radii of the circle. So angle theta here is an example of a central angle. A sector, then, of a circle is the region bound by two radii and the intercepted arc. So you see the two radii and then the intercepted arc. So here's the two radii and then the intercepted arc, everything inside there. So that light blue section is a sector. And we'll define segment now as well. The segment of a circle is the region bound by a chord and its intercepted arc. So you see the chord here, and then the intercepted arc. Inside there is the segment of a circle. So we want to develop the area of a sector and then talk through the area of a segment. Well, the way that I like to think about this is the area of a sector is a fraction of the circle. It's a fraction of the circle. It's not a full circle. It's a fraction of the circle. So it's fraction of a circle. Well, we know that a circle, the area of a circle is pi r squared. But again, we don't want that entire thing. We want the fraction of it. So what we do is we think, how many degrees are in an entire circle? And that is 360 degrees. So if we wanted the entire circle, we would want 360 degrees out of 360 degrees. However, we don't want the entire circle. We only want a fraction of it. And so what fraction do we want? Well, we want theta. We want this many degrees out of the 360. So we have theta over 360 times the area of the circle. So that's the area of our sector, theta over 360 times pi r squared, where theta represents the central angle and r is the radius. So theta equals the central angle and r, we've used that many times, equals the radius. And so that is the area, the formula for area of a sector. Now let's take a look at this segment here, the segment of a circle. Well, what we're going to do here, I'm not going to give a specific formula, well, kind of a formula, but what we're going to do is we're going to realize this segment, if we draw the radii to those endpoints of the chord, we actually, in black, we have the sector of a circle. But we don't want the entire sector. We don't want that entire area. We want only that light blue section. So what we're going to do is we're going to take and realize that the area of a segment of a circle is going to be the area of the sector minus the area of the isosceles triangle that's formed there. So if we subtract out this isosceles triangle, it's isosceles because the radii are the same. So we're going to subtract out the area of the isosceles triangle. And this, obviously, we have over here, this is theta over 360 times pi r squared. And then we'll have the area of the isosceles triangle, which is 1/2 base times height. We'll have to find those in somehow, or they'll have to be given to us. And so this is the concept for area of the segment, and this gets us working towards a formula, although we'll probably have to find some of these different lengths, the radius, the base, and the height as we look through that. So the base would be this length, probably, and the height would be this length. The only thing, if this were a 90-degree angle, we actually could look at the base is this length and the height is this length. So There you have it. The formulas for the area of the sector and segment of a circle.